Okay, this is my second Tesla coil update for the solid state Tesla coil. I've added not very much here, but I've got another 555 timer circuit here and then a new hex inverter circuit here. Both are quite simple, so essentially for a solid state Tesla coil which uses resonant feedback, you want to somehow obtain the frequency at which the secondary coil is switching at, and then use that frequency, that signal feedback, in order to adjust the frequency at which the gate drive transistors are being switched open and closed at. And that will eventually be on the inverter circuit. And if you didn't have this, essentially you would have to just predict and create some sort of timing that would be something roughly close to the actual resonant frequency of the Tesla coil, and that would control the switching. But with a feedback circuit, you can use the feedback so it will self-adjust to get exactly what the frequency, the switching frequency that you want. So really simple here. Essentially, here we have a 5555 timer circuit. This idea was taken from Steve Ward. So this circuit here is something roughly close to the resonant frequency I'm going for. I have my oscilloscope hooked up. You can see in the top left corner there, top right, it's outputting 163 kilohertz. Now, you can see that if I move my oscilloscope probe to the output of this 20k ohm transistor, the signal creates these triangular waves because the rise time and fall time of the output of the timer become slow, so it creates a dampened, weaker looking wave. You can also see down here that the voltage changed from an output of, I think, probably around 5 volts to now 3. So eventually there's going to be an antenna from the secondary coil that hooks up into this hex inverter circuit. But for now, I have this 555 timer circuit to sort of simulate what that would look like. So it would create this weak signal that would go into this hex inverter, and then the hex inverter is going to use its logic gates to then recreate a nice output again. And we're back at 5 volts there at the original frequency of 165 kilohertz, or at least close to it. So the purpose of that is simulating what the secondary signal might look like with this 5555 timer circuit. You can see that it might look wonky, but once we put it into the hex inverter, we can clear up the signal and create a nice square wave out from it. And then that signal, this one here, is going to be good for driving the gate drivers and consequently the inverter transistors. So yeah, that's what we got going here. This 555 timer circuit isn't necessarily needless eventually. So what Steve Ward does is he eventually uses this as a way of sort of kickstarting the process, because when you initially turn on your coil, the secondary is it's not going to immediately be switching at its resonant frequency. It's going to be switching pretty slowly, or something random to start. So instead, if you just use some signal close to the resonant frequency, you can give it sort of a baseline signal to jump to start from. And then by including this transistor here, if you make this much bigger, so this is 20k ohms, but if you make it something like 100k ohms, then the output signal is going to be really weak, and then the secondary coil, once it reaches the resonant frequency, it will sort of override the signal generated by this circuit because the resistor is making the signal so weak. So this 555 timer circuit, I may end up removing it, but I could keep it for sort of that kickstart process, which Steve Ward eventually said wasn't necessary. But anyway, that's what I've got going. Next update will probably be using the UCC gate drivers and throwing them on this board. So stay tuned for that.